Yeah, it should be week 5. So yeah, if you don't have it, you can re-download it. Otherwise, if you have it, you can just use it. No need to change anything. Hey, please let me know if you downloaded all the data set, then we will start. Okay, what about Sherifa, Rabia, and Huma? Did you get the data?
Yes, I have downloaded it.
Okay, thank you. Okay, then I will assume that you have the data. So if you don't, and if it takes time, please download it, and then you can see what I'm doing, and then you will follow later when I give you some more time to do it on your own. So first of all, we are going to import the data set. So the first data set we need to import is Jeju protected step 2.gpkg. Drag and drop. Then you will be able to see a what is wrong with my GIS? Yep. Now you will be able to see this kind of a um, selection window. So let's select the step 2 new. So basically in GPKG itself is called, actually in full name is called geo package, and GPKG itself is a database. So you can have multiple files in one, multiple data sets in one GPKG file. So in this case, because we worked twice during the last week, we have two different sets of data set in one GPKG file. So we are going to use step 2 new. So select it and then add the layer. Let me know if things has done. Gonna wait here. Okay, the first step, what we needed to do is creating a grid. Like when we say renewable energy potential, usually this renewable energy potential means kilowatt hour, megawatt hour, or gigawatt hour per square kilometers, or sometimes kilowatt hour per square meters, or something like that. So we needed to make a sort of grid or box or cell, whatever you want to call, but usually I call it grid, which will have all those potential information for each grid. Right? So we're gonna go to vector and then go down to research tool. Then you can find create grid. So now please click it. Somehow my QGIS is having a little trouble. It's fine. There are multiple types of grids that you can create. First, you have a point, you have a line, and you have rectangle, diamond, and hexagon. We can try all of them, but later. The first thing we want to try is going to be hexagon. Click hexagon, and grid extent means the size of this grid. You can just choose the entire world, or maybe small area or a city or just your country. But in this case, we would like to use this grid for this area, right? So we are going to choose this small triangle, and then we will find calculate from layer, And then which layer is Jeju protected step 2. Now we need to choose the size of the grid. We will make 1 kilometer size. You can change it to kilometer. So there is very interesting thing that you need to remember. There are different types of a CRS. You already know, and one type of CRS is basically like EPSG 5179, which we are using at the moment. This CRS system or coordinate system is based on meter or kilometer. However, if you use WGS CRS system, it will be based on the degree. So 15 degree or like 15 degree and 10 seconds or something like that. So, but that's why we usually, when we do GIS for a country, usually we choose EPSG system because it has a kilometer or meter unit, which is much more useful for a country. But for a country like Russia, Australia, or maybe United States, using EPSG wouldn't be the best solution because the entire country or the entire land area is pretty big. So in that case, maybe WGS system can be much better. So let's choose this one. And then if we run it, it says create grid finished. We created a hexagon here, which has 1 kilometer size. So yeah, but I'm going to give you some more time anyway. So let's zoom in a little because we want to make sure if this is actually a kilometer size. So choose visual line, and then let's just see the size from here to here. It is not actually a kilometer, right? It's about 1 kilometer and 200 meters, 1.2 kilometers, right? What about the other way? This should be much shorter, 570 meters. Where is 1 kilometer? Actually, 1 kilometer is defined by the distance between these two parallel lines. So it's about 1 kilometer, right? So if I click it very correctly, it should be exactly 1 kilometer, but there is no way that I can do it. But this is 1 kilometer. So you need to remember that it is not about this length, it's not about this distance, but it's about the distance between lines that facing each other. Like this. Okay. So yeah, let's make this grid on your own machine and then let's move on. I'm going to give you maybe 1 or 2 minutes. This is not too difficult, so maybe give you just 1 minute and then we wait here. And if you have any question, please let me know. And if you have done it, you please thumb up so that I can move on. Again, to remind you, go to vector and then research tool. You can find create grid, right? Go in and then choose hexagon, which is the one that we are going to use. And then choose the grid extent to be a Jeju protected step 2. And then choose change these meters to kilometers. And then run it. All good? So now I have one person. Okay, I'm going to proceed. So let me know if this is too fast. I'm always checking this message. So please let me know if this is too fast. I can go slow or I can stop in the middle. So yeah. And then next thing, what we need to do is we will create a centroid. Centroid is a point which is basically the center of each grid, right? Type centroid in the processing toolbar. Then double click it. Now, input layer is Jeju protected step 2. Is that correct? Actually, not. We will make centroid for grid. Don't need to save it. Don't need to worry about that part. We can run it. Okay. Let's do it on your own machine. 15 seconds. I will wait. So interesting point that you can see actually is, let's move this grid below centroid so that we can see all of those. I don't like this kind of picture because I don't like circle and I don't like a dot, but we have both here. So if you see the information of this cell, of this one of this cell, it has quite useful information that we can check. So first of all, it has ID and the position, left, top, right, bottom, and then there are some other information. But one of the most important information that we want to have is going to be the ID. ID is a very unique number. So no cells can have the same ID in one layer. And if we click centroid, and if we click the centroid at the same position, then you can see the ID, which is exactly the same, 194, right? So because they are different layers, so they can have a same ID, we are going to use this ID to match the data and to import the data from one information to another. So now what we need is importing, what is that? The raster data. If you go into your drive, and then you can find a Solar, right? Go to Solar, and then there is TIF file, which is global horizontal irradiation. Drag and drop. And then let's move it down, all the way down to between grid and a Jeju protected area, or maybe even below Jeju protected area. Now it has some information. What kind of information is it? It's solar irradiation. If you click on point, it doesn't show you any, but at least we can see the value is between 4.2 and 2.5 or 2.46. The unit of this value is kilowatt hour per square meter. And this data is per day or daily average data. So it means in South Korea, the highest solar irradiation in South Korea per day is 4.262 kilowatt hour per square meter every day. And then the lowest is going to be 2.46. Where is the lowest? Let's check it. Probably the darkest one. So you can see this area, right? Those are the mountainous area in South Korea. So that anyway, because of those, because of the mountain, I mean, the mountain is not really high, but it's about 1,000 meters. But because of the height of the mountain, you can expect a harsh weather, like more rain and more snow in winter, and also much shorter daylight, so that the average global solar irradiation of that area is particularly low. So let's zoom in again. We will sample the raster data. So this raster data has, as you can see here, the global horizontal irradiation data at every single point, right? So we need to import the data or sample the data to vector. There is a function called sample raster. And if you type sample, there is a function called sample raster values, and double click it. So the input layer is going to be the centroid. So as you can see, you can't see any other layer but just the centroid, because that's the reason why we created this centroid data set, centroid layer, because this sample raster value always take point data and point vector and raster layer. Okay, choose centroid, and then input layer is going to be GHI, global global horizontal irradiation. Then don't need to worry about this output column prefix, but if you like, you can change it. I don't know, something like a GHI. Then the information of GHI raster layers information will have a GHI underscore in front of all layers. I will show you all attributes. So let's run it and close it. Okay, let's proceed. Now if we click this data called sample, and if we double click it, we can jump into the attribute properties, not attribute, sorry about that. So properties, and then let's go to fields. As you can see, there is a field called GHI underscore 1. So basically, the global horizontal irradiation raster data had a layer named 1, and we imported it or we sampled it to this vector and then named it GHI underscore 1. So how to bring this first value is sometimes quite critical, so that you might not forget what data you imported. So that's why I put the GHI rather than just the sampled, right? And then let's see if this sampled data has a proper value. Again, let's double click it. And then let's go to symbology. And at the moment, this is just a single symbol. So click it and then change it to something else. I prefer graduated. Graduated. When was the last time that I graduated in school? Yeah, somehow it just popped up. And the value is going to be GHI1, right? And then before we do anything, you can choose equal count or equal interval, but let's try equal count first. And then choose 10 classes here and classify, which is already done. But I want to change the color ramp to spectral. And then as you can see, the higher value has a more greener color and lower value has more red bit more red color, right? But which is usually the opposite. So we are going to change, we are going to invert the coloring. And then, okay. Then as you can see here, there is a point or a point where has bit higher value and where there is bit lower value. If we import this OpenStreetMap, and then if we see them or superimpose them, we can see what happened. The mountainous area, here are a bit more mountainous area. The central area is a bit more mountains. Because of this mountain, you can expect to be more shade, right? Because, and as you can see, here is the south, and in northern hemisphere, usually sun goes from east to south and then west, right? So that there is the shade area, which makes the lower, which lowered the green horizontal irradiation. However, those more like flat land area and then ocean area, you can expect a bit higher global horizontal irradiation. Is this it? No, actually not. There are a couple of things that we need to go through. But before that, um, yeah, I just want to make sure that everyone is here. So yeah, I'm going to wait here about 30 seconds to a minute. So yeah, try it on your own machine and let me know if you are having trouble to follow. I can just repeat, no problem. And yeah, if you have done it, please thumb up for me. No problem. You can double click the sample and then go to symbology and then change. Originally, it should be a single symbol, right? So change it to graduated because this is a graduated, graduational value, which changes continuously, right? So change it to graduated and then set the value to be GHI1, which is global horizontal irradiation. And you can actually change this to something else, whatever you like. But in this case, I'm going to use spectrum. Let's try something else. I really like this Voridis or whatever. I don't know how to call. I like that color ramp. So number of classes is 10. Means entire number will be classed by 10 groups. Can be 15 or whatever you like. Just 10 is normally what the number that I use. And then again, if you see it, more yellow color is higher number and be more purple color is be lower number. If you like this way, it's fine. If you don't like it, click this small triangle and then invert the color ramp and then click OK. Then you can see this result. Okay, now let's proceed. Now, what we needed to do is putting this centroid or sampled value to the grid that we have, because in the end, what we need is not actually the point, but we need the information of the area, right? The area of each cell as well. So what we are going to do is join, type join in processing toolbar. I'm going to give you some more time to do it on your own, so you can just follow it. There are a couple of different types of joining method. Join attribute by field value, join attribute by location, and join attribute by nearest. So yeah, if you have a same field value, always join attribute by field value is the best one because that's the fastest and that's the most accurate. So in case of join by location, you can find or you can join an information from one layer to another vector layer using its intersected area. But it takes more time because you need to calculate if there is intersection with one layer with another. And if there are multiple intersections, that you need to calculate which has the largest area overlapped, right? And then it can deal with the data. It can decide how to deal with the data. Basically, is it going to use the largest overlap information or going to use the first information, whatever you like. So, but in this case, we are going to use join attribute by field value. Double click it. The input layer is going to be sample, and input layer 2 is grid. Let's see how this goes. I think I made it wrong. So input layer is grid. So that is the base layer. And the second input layer is going to be sampled. And here you can see the table field, right? We are going to choose ID because we know this sampled or centroid. The sampled is based on the centroid and the centroid is based on this grid. So we know their ID field has exactly the same value, right? And here is layer 2 field to copy, which means the value, what value you want to copy from a layer 2 to the base layer. So I choose GHI1. And then we're going to run it. It's no problem. It created a new layer called join the layer. You can zoom in, and if you click it, there is ID and there is a size and everything. And then in the end, you can see that GHI1, which is global horizontal irradiation of this cell. Okay. Yeah, I'm going to wait here about 1 minute or 1 or 2 minutes. So please do it on your own machine. Then please let me know if you have done it, or please let me know as well if you have a trouble to follow as well. Now I think everyone must have this join the layer. And you for Hamad, it may take too much time to go back, but just to give you a brief idea, what we have done so far is we created a grid. So you can go to vector and then you can go to research tool and then create grid. So you can create hexagon grid with 1 kilometer of size. And then from using the grid, we created this a centroid. So you can just type centroid, then you can create a centroid which shares exactly the same information with the grid. However, the only difference is if it's a polygon or if it's a point. And then using the point, using the centroid, we sampled raster data, which is global horizontal irradiation. That's what we have done so far. And those data are from last week's data, so you can download it from our drive. So now if we click this join the layer, you can find all the information we need. And what we will need to do is we actually create this protected area. What's the point of this creating? What's the point of having this protected area? And why do we want to use it? How do we want to use it? We will flip this sampled join the layer using this where is it? Jeju protected area. It can be the other way around, but doesn't matter. But I usually do this way. So join the layer with Jeju protected area. Let's clip it. Oh, it says no spatial index exists for input layer. Performance will be severely degraded. It didn't take much time at the moment, but it's fine. Let's have a look at it if it worked fine. If we go to information and if we click just one of the cell, you can see only just one cell is clicked, right? But if we go back to Jeju and then if we click one of it, it basically click the entire area, right? Now this Jeju area has a cell, which is basically a grid. So, but before we jump on, before we jump to the next step, I want to delete it. I just want to show you one thing. We can double click join the layer. And then if we go to source, you can see create spatial index is basically active, right? Nothing to worry, just click it. Now it becomes a inactive, right? Means this layer has a spatial index. If you don't have a spatial index, it takes really long time when you do a bit more complex calculation. So it's kind of a thing that you always need to remember if you created a new layer or if you imported a layer or if you did something with layers, then you need to double check if the result layer has a proper spatial index. If it doesn't have it, it will be active. If it has it, it will be inactive. So as far as it's inactive, it's all fine. Now forget it. And then we can clip again. This time we are going to clip Jeju. No, we are going to clip join the layer using Jeju protected step 2. We are going to run this clip once again. Now it doesn't have any warning, right? It just works, no problem. Let's wait. Do you feel like this is faster than before? I don't know. But if you are working on very large data set, which takes several minutes or sometimes an hours, then this one spatial index will create a huge difference of your life. And now we have this clipped data. Let's move it to the top so that we can see it without any problem. And it's too red, so let's change the color to something else, more light one, maybe something like this. Okay, and then if we click the information, we have the same ID and we have GHI, but also as you can clearly see, all those excluded area are basically excluded from the vector as well, from the polygon as well. Okay, so yeah, I'm going to proceed to probably I'm going to just stop here and I will get any questions for you guys. We'll wait here for about 1 or 2 minutes so that you can proceed to clipping process. While you are doing it, I'm going to wait here anyway. And there is one thing that I want to share. It's you don't need to follow this. You can just listen while you are working on your own machine. There is a difference between clip and intersection. So in case of clip, it literally just clips or it literally cut the vector layers, how do I say, shape. So it doesn't get the information from the overlay layer or the second layer. But if you do intersect, then the information or all the attributes from both layers will be joined into one. Right? So usually clip is much faster than intersect. However, if you actually need to join the data itself or attribute itself, that you need to do the intersect rather than clip. that can create some changes in the result when you are working on your data set. Okay. So yeah, I'm going to stop here and let's have a break. We'll come back on time. So 4 p.m. KST while we are having a coffee or water or tea, whatever you like. I'm going to wait here. So if you have any question, please let me know. And if you're having any trouble, also please let me know. Okay. See you in about a quarter. Thank you, everyone. And then let's jump into the next stage. Thank you, Hamad. And we have this clipped area, and what we need to do now is going to be calculating the potential. This is the key. So let's see this way. So let's double check if this vector layer manipulation has done correctly. We removed all the protected area, and then we removed those road area as well. And as you can see here, there probably some of those parts are not really road, but definitely there are some road. For example, this is a protected area and then road area, as you can see here. And then also if we go down to the little bit more urbanized area, we can see the road, right? So now let's back. How can we calculate the potential? There are two different ways of calculating a solar potential. One is based on the capacity and another is based on the actual global horizontal irradiation. I will go through step by step, so please follow it, and then we'll give you enough time for this case. I give you enough time to do it on your own. Let's double click this clip so that clipped layer so that we can go to the properties and go to field, and then we will edit it. Let's edit this to be daily GHI, because what did I say? I said the unit of this information is kilowatt hour per square meter per single day, right? So what we will need to do is first jump into the field calculator. Why is it here again? And then we will create a, I don't know, land area, a field called the land area. And we will type in area. But it says its expression is invalid. Why? Because we need to also set, or we need to also type in the geometry. The other way that we can do is going to be directly start type area, like with dollar and then area. Remember the value is 7 and 89 and 223, right? If we use this 788 677, you can see the difference, right? There is a big difference. What are they? So for example, if we use dollar area, which is ellipsoid or ellipsoidal land area, which is considered the shape of the land. And the other one is area is basically a spatial reference system based, or basically flat area. So in many cases, so it says plane metric, right? So in many cases, for this kind of small area calculation, the best way is using this plane metric approach. But for when you calculate the entire land area of a country like Brazil or Antarctica, if you use plain land area, the the error is going to be pretty big because, the Earth is sphere, so that makes the big difference, right? However, at the moment, we don't need to worry because the size of this hexagon is only a kilometer wide, right? So we will use area at geometry. So if you see this number 788,677, which is a square meters, okay, calculate it, and we have the land area. Let's see if this value is correct. For example, how do we validate it? Now, this part. So we can click, for example, something with a full shape. Yeah, there is one. Then each side land area is 866,025, right? 866,000. If we click one of these cell, it becomes 7,500, 705, 9,200. If we go a bit more outside, so it becomes only about 567,000, right? Now we can make sure we just validated if the calculation was correct. Now we have the land area. Before we forget, let's save it. And then let's go into this field calculator once again. The second thing that we need to calculate is going to be a capacity over the area. I mean capacity of the solar panel that we can build in this given area, right? So we will type in capacity. What is the power density of solar panel? Solar panel's power density is about 150 watt per square kilometer. That's basically a power density. So we are going to use 150 multiplied with land area. In this case, we are going to have a full capacity. Okay. And what is the unit? It's watt. So watt is just a the number is going to be too big if we keep using watt. So let's make it to a megawatt. It's a megawatt, right? So yeah. So I'm going to name it as capacity underscore megawatt. I'm going to wait here and we'll give you some time to calculate on your own machine. So we'll wait here about 2 minutes. I told you that there are two different ways of estimating the potential. First is based on the capacity, which we already have here, right? In this case, you should know, basically, you should know the capacity factor of the system or of your region. I mean, it's usually quite well known because you can find it on your own, like utility company's data set or governmental data set and etc. Let's try it that way first. So this case, potential one, that's what I'm going to name, and going to be megawatt hour unit, right? And then in this case, this will be a decimal number. So far, we used all integer numbers. So the land area actually doesn't have any so 0.1 or 0.2 or something like that. It's all integer. But now we will need a bit more real numbers. Now what we are going to use is going to be capacity megawatt, and this is a capacity of a certain moment. So to be a potential, usually when we say potential, it is annual generation. So we need to multiply it with 8,760. Of course, there are gap years. However, when you calculate potential, you just ignore it. 8,760 is basically a annual output. Is this it? If this is it, then it is just too simple because this is not how things work. You need to multiply it with um, capacity factor, 0. Let's say 1.5, usually 15% of capacity factor is pretty big, pretty good enough in most Asian countries. So yeah, capacity factor is 0.15. And if you run it, this is one way of calculating the capacity, generation potential. We are going to go into property again and go to symbology and then change to graduated. And we will see how this potential is different by region using a inverted, what is it? Inverted spectral ramp, color ramp. And again, we will have 10 classes. It's 5, then okay. Now we have a quite good result for this. If we zoom in a little, you can see those area is has a quite big potential electric solar photovoltaic potential. Although um, the global horizon irradiation was pretty high around those flat land area at the moment. It was not properly considered because we just used capacity, which means basically land area is the biggest factor deciding the potential. Okay, let's calculate it again. Let's calculate it on your own machine. I calculate the potential 1, and then what I did was basically the calculation was like this. What is wrong? Yeah, capacity multiplied by 8,760 multiplied by 0.15, which is the capacity factor. Do it on your own computer and we'll be back in about 30 seconds. Okay, yeah, it shouldn't be too difficult, right? So this is one of the potential that we have, and we are going to try another way of calculating the potential that we will use a global horizon, um, global horizon irradiation, and we'll compare the difference. Okay, let's go into the field calculator again. I will name it potential 2 with megawatt hour, and then it will be a real, not integer. So to calculate the potential using global horizon irradiation, first we need a basically global horizon. I forgot the name of this attribute. Don't worry, you can always go to the search field and then go to like Is it somewhere in variable, or I can't remember exactly where it is. Let's see the field. You can go to the field and you can find, okay, daily GHI. It was daily GHI. And we know, I already explained that it was a daily global horizon irradiation. So we need to multiply it with 365 to be a yearly output. And this output is kilowatt hour, but we want to make it as megawatt hour, right? And multiply it with 1,000. This already became a quite big number. But is this it? Is this all that we need to have? Actually, not actually. We need to add a efficiency because previously we used capacity factor and the capacity of the system to calculate the output. So the capacity factor is fixed. However, in this case, we are going to calculate the output of the system using the global horizon irradiation, global horizontal irradiation. Why am I saying horizon? Horizontal irradiation. And in this case, there is a bit of energy from the sunshine, and then the system will convert this energy into electricity. So we need to apply the energy efficiency here, which is going to be about 20%. So this is a potential 2. Daily GHI multiplied by 365 and then multiplied by 1,000 to change the unit from kilowatt hour to a zero 0.2. That's it? Actually not. We missed one more thing. The unit of this, I think I made something very stupid mistake. Actually, we need to divide by 1,000 to be megawatt hours, right? And what we need to consider is land area, right? The global horizontal irradiation is kilowatt hour per square meter. So we need to multiply the land area so that we can have the number for the entire cell, right? We will calculate it. And then if we see one of the cell here, it will show us a pretty big difference. Based on what method you choose, actually the output can be quite different, right? Some area might have a pretty similar number, but some area might not. Depends on each capacity factor and depends on the energy efficiency that you used. So we'll wait here for about a minute to let you to calculate this potential using global horizontal irradiation. And here I will write down the equation once again. This capacity multiplied by no, divide by 1,000 and multiplied by, what was it? 365 and multiplied by 0.2, which is the efficiency that we assumed, and then multiplied by land area. This is correct, right? No, sorry. This shouldn't be capacity. Daily GHI. This is the equation. We'll wait here about a minute, so try it on your own computer and then compare two different results. Okay, then I think everyone is following so far, so good. So let's do the next process. So we have the potential and we have the capacity. What is going to be the last one that we will need to calculate? It is a capacity factor again. So let's calculate the capacity factor. Create a new field and then make real, and you can just type CF. We have all the data here. First output that we will need is potential 2 per megawatt hour. If we use potential 1 per megawatt hour, each output is going to be just 0.15, which is 15%. Let's use this potential 2 per megawatt hour. And then this is a annual data set. So we need to divide it down to 8,760 to be an hourly, right? And then divide it with capacity per megawatt. Then this will provide a capacity factor. Do it on your own computer. I'm going to wait here before I run it about 30 seconds, and then we move on. Okay, then now we can run it. Then we have a capacity factor here. Let's see how the capacity factor would look like. First, we go to view and then go all the way down to panel. And then we have statistics. Click it. Make the other part a little smaller so that you can see the value a bit more clearly. For the statistics, we are going to choose join the layer. That's the one, no, sorry, clip. That's the one that we've been working so far. And then choose the CF, capacity factor. And this will calculate the statistics of this data set. First, we have 350 data sets here, or 350 cells. And then its total value is 72. However, in this case, this total value means nothing to us, right? What we want to see is its mean value is 20, about 0.20 means 20%. And its median is also about 20. The thing is, as I told you before, in South Korea, capacity factor almost never exceed 15%, which means first, either this data, global horizontal irradiation data itself is overestimated, likely, or the energy efficiency of the system is overestimated. It's basically one of each, right? So which one is more likely? We don't know. However, at least we know that there is a problem so that we can add a adjuster later. And its minimum is 0.172 and maximum is 0.26. So yeah, 0.26 will never happen. I mean, yeah, even 10 years later, 0.26 or 26.7% of a um, capacity factor in South Korea is not going to be happen at all, never. And another thing that we can think of is this data that we used is actually a data average, daily average data. Probably there might be some data processing issue when this global horizontal irradiation pattern became just a single number. I don't know what was the problem, but at least we know there is a problem. So in this case, what usually we can do is there is almost nothing. Unless you are 100% sure that this value just totally doesn't make sense, then you can create a new one. And then you can add some adjuster, like say multiplied by 0.7, or you can reduce the energy efficiency of the system. Yeah, and that way you can adjust the mismatch with a theoretical output and the real or more technical output. Okay, and yeah, this is all about a solar potential calculation basically. But there are a couple more things I want to share so that you can have a chance to calculate or you can get used to using QGIS a little more. So the first thing that we should think about is land area. Is the entire land area is basically usable or not? What do you think? Is the entire land area is usable? I'm going to show you just one small picture. Let's see if I can find it really fast. So, okay, yeah, I found it. So here's the thing. So this is a solar farm. You can see the panel, but is it covered the entire land area? Actually not. The solar panel covered maybe less than half of the land area. Why is it? Because if solar panels are overlapped to each other, it will actually create shade. As you can see, probably if these two solar panels are close to each other too much, then the the shade of the front solar panel will affect the output of the solar panel behind, right? So that you almost always you need some gap between solar panels. And instead it just a gap? No, actually, because the solar panel itself has a shape or the length and the size, right? So that you can't have an entire land area you can't build the solar panel to the entire land area. Although, for example, in this case, project area is about this, you can see some empty area around here, right? And then technically, there is another reason why you cannot use the entire land area because you need a small buildings and places where you install inverters and other like um, electricity transmission systems or distribution systems or power lines, and also maintenance area and etc. So when you calculate the potential, usually what happens is, let's jump in. What happens is you need to have a something like this land area um, uh, 0.5 or something like that. I'm having trouble with my keyboard. So what does it mean? So land area multiplied by 0.5. This means we are going to give up about half of the land area for operation management or something else. We are not going to use them, and we are going to use only the half of the land area. This is more realistic. And in case of agri-photovoltaic, this land area is going to be about land coverage rate is going to be about 30%, less than 30%. 30% is basically the best you can see. However, in case of utility, it can go up to about 90%, depending on the land shape and the location of your country. For example, if you are if you are living in a country close to equator, then the sunshine is going to be more direct and vertical, so that you don't need much land area to spare. However, in case of South Korea, you you definitely need to spare some land area to avoid the shade. Okay, I will give you about 2 minutes from now on. Please calculate the land area with about half, but based on the assumption that half the land area can be used, and then recalculate the potential using this one. What you can actually check is you can go to Google Maps. Let's try it together. What's gonna happen? Um, you can go to Google Map and you can check around any buildings that you know. So probably, I don't know if I can find the proper building with solar panel in South Korea because rooftop solar panel is not really widely accepted in Korea yet. However, probably there are some buildings like factories around, I'm pretty sure. Resolution is too low. Let's go down a little more. Something probably here. Mm. Yeah, unfortunately, the resolution is pretty low here, but yeah, there are some solar panels, as you can see, is covered quite well. In old days, in case of rooftop solar panel, we assumed about 0.0, about 50% of area can be used. Rooftop solar panel, however, these days, there are quite good techniques and engineering approaches that can provide a bit higher coverage rate. So probably you can assume a little more, but it depends. For example, if the rooftop solar panel is like totally attached to the roof, then it's less than 50%, about 30% would be quite kind of acceptable. However, in case of a rooftop solar panel in factory building, it can have a bit different picture. Let's see. There must be something very good example that I want to share. Yeah, something like this. It can cover pretty large area of the rooftop, right? And then, yeah, and then here is another one. The thing is, this is very interesting one. It actually quite dependent on the shape of the roof. If the roof has a direction to the south, so for example, one side is totally facing south, then it is really good area. However, in that case, the other area is going to be faced north. So in northern hemisphere, that is not a good sign. Of course, you can have some more structure to use this northern face. However, in the case, you will not be able to use this southern face. So rather than using a structure which is quite expensive, it might be better to use it. So it depends on. So you need to when you want to calculate the potential, particularly for the rooftop, you need to look around the area where you want to study. So if you study the area, definitely you can see how this rooftop will be, how this rooftop solar panel is going to be installed. I hope this answered. Okay, yeah, there are a couple more things before actually in the next week, we are going to calculate, wind potential and some other things using basically the same data set. However, thank you, Aisha. Before we jump into the next step, directly, I want to share a couple more, like a techniques based on my experience. When you work on GIS, as you might already notice, you need to do the same process again and again. So in this case, to calculate the potential, let's just think about it. What was the first step? The first step that we did was getting all the data, of course. And then second, get the base map. And third, calculate the difference between the base map and the protected area. Calculate the difference between this base map with a road, and then calculate difference between the previous layer with a houses, and then calculate the difference. you already got the point. We are calculating the difference again and again, again and again. Basically, you need to do, if you, for example, in case of South Korea, there are about 25 to 30 different types of layers that we need to exclude by law. In that case, you need to calculate the difference only exactly the same process. You need to do exactly the same process 25 to 30 times, which is pretty annoying, right? Of course, there are some others way there are some better method to do it. First, you can type difference in, because usually when you calculate when you need to do the same process again and again, mostly it is difference in many cases. So you go to difference with multiple. Now what you have is you have input layer. Let's choose this one. And then you can have overlay layer. Hey, that's fantastic, right? You can choose as many layers as you want. And then if you run it, if we actually run this one, in the end, we are going to have nothing because it will it will basically do the self-exclusion. But this is one way you can just do it. When you have base map and when you have overlay layers, multiple overlay layers, you can use a difference with multiple. Then you don't need to worry doing the same process so many times. That's one tip. There is another tip. We know that there are 40, like 25 or 30 different layers that we need to exclude from the base map. So this is basically a mathematical, primary school mathematics. We can do A minus B minus C minus D minus E and minus F and etc. and etc. So go on and go on. We can do in different way. A minus sum of B, C, D, E, F, right? So before we do the difference, we can actually, what was it? I just forgot the name, union. We can actually run the union, and even for the union, if we have 25 layers to make just one layer, if you use just normal union, then ended up having the same process again and again, like input layer and overlay layer, and then output becomes input layer and then overlay another one. However, if we just use union, then we have input layer, and then we can choose as many as we want. Let's say sample and J's and D's, and then we can just run it. After that, using the output of this multiple union as a overlay layer, we can exclude this overlay layer from the base layer. That will save your time a lot. Okay? And this is not it. I already gave you 2 tips, right? There is another way that we can do is jump into union. This is a slightly different situation. When you need to do the process, but you don't want to do the process to the same base layer, or you need to make a different output. For example, you need to have an output like base layer and base map is minus road. And also you need output of base map minus or base map minus a protected area. And you also need the output of base map minus, say, houses. So we need 3 different types of output. The first one is always the base map, and the second overlay layer are all different. What is going to be the easiest way to run it? Of course, you can do it one by one. You can run input layer, overlay layer, and wait until it finishes, and then input layer and overlay layer, another one, and wait. But it's boring. right? So we have run as a batch process. Every single function has this batch process function. So if you dissolve, you can have run as batch process. Almost every single function has it. If you click it, now the things can be quite different. The first input layer is clicked and the overlay layer is going to be centroid. We are going to unite them and then add another one. Click the layer and then probably, I don't know, grid layer or something like that. What if we have more? Like we can add as much as we want, but oops, I want to change the input layer. Let's change it to grid. But I want to change everything to grid. You have a function called autofill. Click it and fill down. Everything became grid. And here you can click it and also you can just fill down, or you can choose like add all files from a dictionary. Basically, you can create just a line of this bunch of this a batch process by just one click. As you see here, I just clicked a directory. As you can see, every single files are included here. They are all the layers are included basically. And then this is the output. You can choose the output directory. Let's say this is the output directory, and then do not want to fill. Somehow it's going somewhere. However, let's see where it didn't run. Yeah, it's behind. So, and then you can drill down, then you will have, unfortunately, you will have exactly the same number, same output. Is this one you want? Actually, you can add value by expression, or you can also have a different way of filling down. Yeah, you can use this expression to have different file name, or you can add something like a underscore 1, 2, 3, 4, 5, 6 or something like that when you save the file. Okay, this is a small kind of tip that you will use quite a lot of time if you work on QGIS. Um, I don't know for your own project. Okay, thank you so much for today's lecture, joining today's lecture, and hope you actually learned something from this lecture. And if you have any trouble, please let me know. And if you have any question, you can just send an email to me directly. I'll be more than happy to support your research project.